do you mean by static time analysis?
STA is the check-in, like it's we check the timing related inquiries while our design is met the actual timing constraints with respect to what we are designing. That's done by in STA.
May I?
Yes.
So basically, STA stands for static timing analysis. It is done out statistically, where it doesn't depend upon the data that is present on the input pins. And the basic purpose of STA it is to make sure whether the circuit that we are going to design is meeting the timing requirements or not, and it also makes sure that if the circuit that we are going to design, it works at the speed that we want it to work, and it works every time or not.
Okay. Sai Shivang.
Yes, sir.
Same question for you.
Yes, same way as Kushi said. It is a static timing analysis used to verify the data speed. Data is whether it is reaching correctly or not to the other flip-flop. To meet the timing requirements, we will do the STA.
Okay. Next question for you, Shidu. What do you mean by clock domain crossing?
Clock domain crossing of CTC, if our circuit work with if the entire design work with different clocks, that may comes from the same source or a different source. If working with the different clock frequencies, then we can say that it's kind of clock domain crossing. Our circuit is in clock domain crossing. If you take an example, if you done one operation with respect to one clock frequency and other operation with respect to another clock frequency, then the circuit is set as in different clock domains.
So, what are the various problems caused in clock domain crossing? Kushi.
Sorry, like I don't study about clock domain crossing in STA, so I just study about STA basics only.
Sai Shivang, can you tell me?
No, I don't have.
Okay. Shidu, tell me the conditions for hold time. Tell me what you mean by setup time and hold time.
If you take a launch flow, family capture flow with an example, because all we done in an RTL level is register to register data transfer. Likewise, we take an example of launch and capture flow. When the data is transferred from the launch flow, it must be captured in the capture flow. If not, then it will be a setup time violation. And the hold time violation is with respect to the launch flow. The data must be, input data must be stable after some time. That's per our requirement. After some time, when the clock edge comes.
Okay. Kushi, you tell me. Same question. Same question for you, Kushi. Hello, am I audible? Hello, am I audible?
Yeah.
Yes. Same question for you. What do you mean by setup time and hold time violation?
Basically, setup time is the time before the clock edge that the input needs to be stable so that it is properly accepted by the clock edge. And the main condition for the setup time is required time should be greater than the arrival time. And in hold time, it is the time after the clock edge that input should be stable so that it is properly accepted by the clock edge. And the main condition for the hold time analysis is the arrival time is greater than equals to the required time.
Okay. Sai Shivang.
Yes, sir.
What are the conditions for the setup time and hold time?
To meet the setup time, the data should be reached earlier to the flip-flop before the activate of the clock, and for the whole time, the data should be stable after the activate of the clock, so that the flop can capture it.
No, I am asking the conditions.
Conditions.
Yeah, in terms of formula.
Okay. Formula. Okay. For setup time, it is time clock freak. One second. Capital time period is greater than equal to TD means TPD means propagation delay from clock to queue plus combination delay and plus setup time. And
Repeat.
capital T is greater than equal to TPD plus TCQ TPCQ plus T setup.
Okay. Shiju, you tell me the conditions for hold time in terms of the hold time
Yeah.
formula.
Conditions that I already tell you in terms of formula means the data should be stable after the clock edge. Then also it will be do proper sampling. Otherwise, data might be if chance. In terms of formula means
In
in terms
terms
of
of
formula.
you can
Terms
say hold time constant. What are the conditions for hold time violation?
in terms of formula, I don't know, sir.
Okay. Puchi, what do you mean by clock to queue delay? Uh, what do you mean by clock to queue delay?
Clock to queue delay. Uh, is it clock to queue delay now?
Yes, clock to queue delay.
So clock to queue delay is
Mm, Okay, Shiju, you tell me what do you mean by clock to queue
So it is with respect to the cell. If we take as a launch flow for capture flow, each has clock to queue delay. It is the time taken between the clock applied and the inside some operations it will happen. If you take an example of D flip flop, we given the input of the flip flop with respect to one time, and the output is given after some time in output pin of the queue. This time is taken as clock to queue delay.
Okay, Sai Shivang, you tell me. You tell me clock to queue delay.
Clock to queue delay is time difference between the clock to the input of the flip flop and the output we are getting from the queue from the flip flop.
Okay. Shiju, you tell me what are the various methods through which we can uh, reduce our timing delay problems.
Timing relay problems in setup and hold time. We take various methods. In RTL designers, they are actually do what is they put a combinational circuit in between the path and make the timing requirements. If we put a combinational circuit in between the path, we want to make sure that the output data does not vary with respect to the combinational circuit what we have put, and some buffer is added to the clock circuit. Then we can actually not vary the frequency, we can vary the timing delays as per our requirement. When comes into PD peoples, they have actually inbuilt cells with different already fixed timing requirements. Cells, they are actually changing the cells with respect to the violation. And then actually if you put the if you change any kind of any changes what we make in the clock path now, then we want to make ensure this clock path is consider want to consider this clock for all the other circuit too. So actually the clock buffer clocking is not a proper method, I think.
Okay, Kushi, you tell me if what will happen if we don't add the buffer clock uh, in this
So
code.
if we don't add the buffer, then we will face hold violation also, because we are increasing the routing path, and due to which we cannot get the correct data at the capture block. And yeah, we don't add the buffers.
So, Sai Shivang, you tell me if we don't add buffer in between the two flip-flops, what
Okay.
will happen? If we don't add buffer in between the two flip-flops, what problem can we face?
If you don't add the buffer, right? Okay. Then setup problem can arise if the clock
Uh,
frequency is too high.
what will be the proper terminology of the problem that we face? Okay. Uh, will you
And
tell me what is my meta stability?
meta stability.
Uh, okay. I already say if we have a clock and with respect to input, if we change the clock and the input in same time, we cannot sample the data correctly. It will goes to a metastability state. So that's why we put a some areas like setup time and hold time, and assume that we cannot have the permitted to change the data in between the setup and hold time. If the input data is changed in between the setup and hold time, it will leads to the setup and hold time violations. So the data may comes in the secure may comes into metastability state. We cannot sample the data properly.
Uh, could you tell me when does meta stability state occur?
What is
When does meta stability state occur?
metastability? What
Uh,
is
uh,
so? Metastability is an unstable equilibrium state where the sequential element is unable to resolve the state of the input signal, and it is in a state. It is not in a stable state between a 0 and the 1. That's
so, Sai Shivan, you tell me what do you mean by slack?
Slack. Slack is the difference between the data path time, the data arrival, and the actual time. It's requirement minus and arrival time.
Okay, Shiji, you tell me what do you mean by slack? Mm. Your mic is off. Shiji, your mic is off.
Oh, slack is the time difference between T and 8, required time and the actual arrival time.
Uh, uh, Kushi, you tell me how do you check force? Can you give me some examples of what can be achieved using static timing analysis?
can you just increase your voice? Like your voice is lagging, and I can't be able to hear your voice.
Okay, okay, wait. I I should rejoin. Uh, yes, Kushi. Can you tell me the difference between intra-clock domain and inter-clock domain?
So no, I haven't read about it.
So, anyone?
Uh, I think CDC I already said that it's a different clock. I think intra and intra with respect to if the source is different, then it is inter clock domain. If the clock is same, then it is intra clock domain. Steady state thing. We can also make the clock diver in between from the same source and control over the frequencies happen like this. Then it is inter. Actually, I don't notice whether history.
Okay. Sai, what is the purpose of slack calculation in STA?
To check the whole setup and hold violations.
Okay. Anything else? Kushi, you tell me. Same question for you.
What is the? Can you just repeat the question?
Can you tell me what's the purpose of slack calculation in STA?
Slack calculation.
Hmm.
Basically, slack is used to calculate the hold and the hold violation and the setup violation, because if the okay. There is a positive slack and the negative slack. If we have the positive slack, it means that the circuit that we are going to design, it is meeting the time requirement, and it is proper and it works every time. If we have a negative slack, means if the difference between the required time and the arrival time is negative, then it means that we have a negative slack, and it shows that the circuit that we have designed is not meeting the time requirement, and it will not work at the speed that we want it to work, and it will not work every time.
Okay. Sai Shiva, can you tell me which is more favorable, positive slack or negative slack?
Positive slack.
Why?
A negative slack indicates the violation.
Okay, and in positive slack?
Positive slack indicates that in case of setup, it indicates that yes, we can increase the speed, clock frequency a bit till the slack is 0 or greater than.
Okay, what should be the conditions for frequency in static timing analysis?
What's the need of frequency, or what's the importance of the frequency?
What's the importance of frequency?
Importance of frequency. Every circuit have a certain frequency as per the user or the designer want. We set as per that frequency. The frequencies tell the performance of the circuit. The data transfer is happens with respect to timing. It will be have a high time or not, likewise.
Pushi, which is more favorable, high frequency or low frequency?
Sir, I think low frequency, because if we work at high frequency, then there is a delay should be, because frequency is equals to 1 by t. If we increase the frequency, then we have the time delay also in the circuit. So that's why.
Okay. Sai Shivang, same question for you.
It depends on the combinational delay between the two flip-flops. If it is less than high frequency is until we are meeting setup violations.
Okay. Shiju, you tell me, how can we reduce power using static time analysis?
Reduce power. Hello.
Yes. Hello.
Reduce power in terms of what? In terms of if you take in the clock, there are one of the method is clock gating, and that's the reduction of the clock, reducing the clock, like what to say. In every circuit is work with respect to some clock frequency or clock. Some of the circuit may not need clock in some time, what we are do is at that time we will not provide clock for that circuit. We gated over the clock in between some circuit, that's termed as clock gating. And other terminologies, other terminology like that's I no sir. If you say with respect to anything, I can explain.
You can say in terms of static power and also dynamic power.
Static power and dynamic power, I don't know sir, I want to go through.
Okushi, can you tell me what do you mean by static power and dynamic power?
So basically, static power is the power that is used during a static time analysis, and dynamic power is during.
Sai Shivam?
Hello, sir. Static power in case of if we consider the CMOS inverter, if the inverter is in stable state, that is either on or off, then we can have a means leakage from the from the MOSFETs. That is called the static power, means static power dissipation. And while switching the means while it is conducting, means it is transition from 0 to 1 or 1 to 0, we will get there is a slight path where the PMOS and MOS both will be on at a particular time, short period of time. That time we will get the dynamic current from VDD to ground. In that case, you will get the dynamic power, means dynamic yes
Okay.
power dissipation.
Can you tell me the equation for dynamic power in CMOS?
Equation 1/2 C VDD square F.
Anyone?
No sir.
Okay. What do you mean by false path, Kushi?
So false path is a path that is physically exist in the design, but logically, or we can say that functionally it is inactive. And in false path, no data is transmitted from start point to the end point.
Okay, Shiju?
False path is came from the difference of arrival of in I think different clock. We want to tell the tool whether is the path is true or false. Like what I say, if the clock different working CDC different clock domain, then we cannot make ensure that the setup and hold time met the requirement in every time. Sometime it may leads to the failure and sometime it will work properly. Likewise.
Oh, okay, Sai Shivam?
Yes, sir.
Same question for you.
False path is like in HDR we consider the path which is of maximum delay, having maximum delay for setup time. The other paths we consider as false path, means we are not using for that for static analysis.
Okay, Kushi, can you explain jitter?
Sorry.
Can you explain? Can you explain? What?
Like voice is lagging. I can't hear.
Am I audible?
Huh.
Yes. My question. What do you mean by global skew and local skew?
Okay. Global skew and local skew. Basically, global skew, it is the difference between the maximum insertion delay and the minimum insertion delay. And local skew.
Sai,
Sorry, sir, I have no idea.
Shiju?
Yes, sir.
Okay. So I think that would be enough for today. I will continue this STA question by tomorrow. So be, be prepared for tomorrow for more higher level of questions in STA. So am I audible?
Yes, sir.
Uh-huh. So I will ask some more questions in STA. It was just the basic questions. So I will ask some good questions by tomorrow. So